Hello, this is the seventh and penultimate video in the C5 quantitative analysis series from Darton College's Science Department. My name is Mr. Clee, and the video itself is on the difference between strength and concentration in acids. Okay, after watching this video, the aim is that you should be able to describe acids in terms of their pH, linking in hydrogen ion concentration and electrical conductivity. We should also be able to use the ideas about equilibrium from the last video to explain the difference between strong and weak acids, and describe and explain similarities and differences in reactivity of strong and weak acids. So there are four key terms you need to be aware of in this lesson. They come in pairs. The first pair of terms are strong and weak. The second pair of terms that you need to be aware of are concentrated and dilute. They're often used interchangeably in chemistry, but they mean very, very different things. Concentrated is how much of the compound is dissolved in the water, given in the normal units of grams per dm3. Whereas strong and weak is to do with the number of and the proportion of free hydrogen ions that are contained within the acid, and that can be very different even for two acids that have the same concentration. So here we go. Firstly, concentration. This is a measure of the amount of acid dissolved in the liquid, and it's always in moles of acid in litres. The higher the concentration, the more number of moles. And then we have strength. This is the more complicated idea. It's a measure of how ionized the acid is in water. A strong acid, like this one here, hydrochloric acid, will completely ionize. That means that when you put the hydrogen chloride gas into water, it will split completely into hydrogen ions and chloride ions. So it is fully ionized, and it is a strong acid. Whereas with a weaker acid, you will have incomplete dissociation, and it will not be fully ionized. So only some of the hydrogen ions present will be free and able to react as an acid does. Wow, so this hasn't come through very well, but essentially, hopefully we should be able to make some sense of this. What we have is weak acids. So weak acids, we don't get full dissociation. So here, what you have is ethanoic acid, the compound. Now, when ethanoic acid dissolves in water, it splits. It splits into hydrogen ions and this negative ion here, ethanoate ion. It's the amount of these that there are that determines how strong that acid is. And the problem that we've got is it's an equilibrium reaction. It is a reversible reaction. Now at the moment the position is quite a long way to the left hand side, which means that most of the solute exists in the form of the ethanoic acid. So only a small proportion of the hydrogen ions, about 1 in 1,000, are available to react, unlike the strong acid where every single hydrogen ion is available. A way to tell, other than using pH, how strong an acid is to use electricity. Charged particles carry electricity. So if you have in an acid hydrogen ions, they will carry charge. The more hydrogen ions are present, the more charge will be carried through that acid. So here you have two situations where you have a strong acid there with an ammeter reading of 4.47 and a weak acid there which has an ammeter reading of 0.03. They're both acid, they're both conducting electricity, they've both got charged particles. But the amount of charge that can flow through those acids is very, very different because of the big difference in the number of hydrogen ions that are present. We need to link that idea to reactivity. So here's one context that we're going to try and put it in. This is limescale, and when you need to descale this limescale, which is calcium carbonate, you react it with an acid to remove the calcium carbonate so that the element can work. If you use a strong acid, chances are it's going to start reacting with a metal, so you tend to use a weak acid. Right, here is strong and weak acid reacted. On the left hand side, this is the strong acid. This is probably hydrochloric acid reacting with magnesium. When it does so, it reacts vigorously at the top, producing a lot of hydrogen gas. In this reaction here, this is the same reaction but happening much slower. This is ethanoic acid. The bubbles are spread throughout the mixture, that's why you get this cloudy appearance, but hydrogen gas is still being produced. That reaction will be much slower, but will produce the same amount of gas in the end. That's because as the hydrogen ions are removed, because this is a reversible reaction, more of the ethanoic acid will dissociate to create more hydrogen ions as more is removed through reacting. So in better terms, hydrochloric acid reacts more quickly with magnesium and with calcium carbonate than ethanoic because it's a strong acid. That means at the same concentration it has a greater concentration of hydrogen ions, so the collision frequency is greater and the rate of reaction is higher. You can tell from this graph that the rate of reaction is higher because the gradient of the graph is much steeper. However, they level off at exactly the same point. That means the amount of gas is the same, but the rate of reaction is different. So they both contain the same amount of hydrogen. It's just because it's not fully available in the ethanoic acid, then it takes much longer to get to the end point, but the end point does not move. So just to be 100% clear on that, the volume of gas produced depends on the amount of reactant, so the concentration, rather than the strength of the acid, rather than how much hydrogen is dissociated. So in summary, strong acids, fully ionized, high concentration of hydrogen ions, so react faster and conduct electricity more easily. Weak acids are involved in equilibrium reactions which are far to the left, so they're not fully ionized, they have a low concentration of hydrogen ions, they react slowly and conduct less electricity. And reactions involving acids at the same concentration will finish at the same point, but the rate of reaction with the weak acid will be much slower because of the lower availability of the hydrogen ions. Sometimes these hydrogen ions are called protons. I probably should have said that earlier. Right, thanks very much for watching. My name is Mr. Clee. If you need any more information about this, please get in touch with me or any of your science teachers.